Welcome back to PreCalc Notes. This is 2.05 PreCalc. We are talking today about polynomials. So more like of what we did last class, and we're going to continue that for the next couple of days. So polynomials with real and non-real zeros. Real and non-real zeros. Dun, dun, dun. Okay, let's talk about the linear factorization theorem. Linear factorization theorem. Here it goes. If f of x is a polynomial of degree n, so the highest, just degree n, where n is greater than 0, then that means f, your function f, has n linear factors. Kind of like it means that you have n number of roots. So you'd have n number of roots and n number of linear factors. Well, what's a linear factor, you might ask? Well, linear factors are factors, so in the parentheses, where you have x to the first power. So something's being added or subtracted to that x. It could be radicals, it could be imaginary numbers, but it starts with just x to the first. It could be x plus 3i. It could be x minus 2 minus rad 6. It could just be x plus 5. Those are all linear factors, but what they have in common is it's x to the first. Just like a line is y equals mx plus b, x is to the first power. Number 1, write as a product of linear factors and then determine the zeros. Of f of x equals x to the third plus 4x. Here we go. If we want linear factors, we're going to look at this and we're going to say, oh, well, first thing I always look for is a GCF. So I take out my x, which I'm dividing each of these by x then, leaving me with x squared plus 4. Further, because we want to get it into linear factors. So what I want you to do is think about x squared plus 4 as a difference of two squares, but we need to make it look like that first. So we're going to do x squared minus negative 4. So minus a negative 4 is the same thing as a positive. So I haven't changed this at all. I've just made it look different. I've said minus a negative instead of plus a positive. So now I can treat this like a difference of two squares. How do I factor that? Well, I would take, so I'll bring down my x, and I'm looking at this one over here. So I take the square root of x squared is x, and then I take the square root of negative 4. The square root of negative 4, if there's a negative under the radical, I have to pull out an I. The square root of 4 is 2. So I would have positive 2i and minus 2i. So the reason we've always said you can't factor using dots if it's addition, difference of two squares, is because you end up with imaginary answers. So if you see a sum of two squares here, then you're just going to do it just like you would a difference of two squares, your dots, except you're taking the square root of negative 4. So it's x plus 2i, x minus 2i. And if you need to just kind of wrap your head around why this works, try foiling it out to see what you get. Well, you get x squared plus 2xi minus 2xi in the middle, and then your last terms would be minus 4i squared. Middle terms cancel. I squared is negative 1, so you get negative 4 times negative 1 which is x plus 4. So that's just a little side note to kind of prove to you that that's what you get. Okay, so now if I want to find, so this right here would be my product of linear factors, because all of the x's are to the first power. Now it said to also determine the zeros. So that means I need to put a 0 in for y. And then I'm just going to solve this for x, so setting each factor equal to 0. And solve for x. So I get x equals positive 2i, x equals negative 2i, and x equals 0. Now think about if you had solved it from up here, you would have gotten the same thing, because you would have set x squared equal to negative 4, taken the square root of both sides, and then had plus or minus 2i. So it's still the same thing, it's just we wanted you to take it a step further and write it as linear factors. Next, we're going to talk about the complex zero theorem. So what that says is that complex zeros are always going to occur in pairs. Thus, if a plus bi, a complex number, is a 0 of a function, then a minus bi, so its conjugate, is also a 0. So they occur in pairs. Number 2, find a 4th degree polynomial with real coefficients that has, we're going to have to go to the next page, -1, another -1, and 3i as zeros. We'll go down to here. All right, so if we know that those are our zeros, if 3i is a 0, a complex number, therefore we know -3i must also be a 0, because they're always going to occur in pairs. Same thing with your radical numbers, 1 plus rad 2, then you'd also have 1 minus radical 2. So we want to find a polynomial to represent these. So those are 1, 2, 3, 4 zeros. It's a 4th degree polynomial, so that means it has 4 zeros. So what we're going to do for this one, because it's not a binomial, we're just going to take each root and write it as a factor. So if -1 is my first factor, or first root, or 0, I want to write it as a factor. So that would be x plus 1. So if I said x plus 1 equal to 0, I would get my 0 of -1. I'm going to do that again for my next -1. Now for 3i right here, again, we want to do the opposite sign. So x minus 3i. And then for this one over here, we change the sign to be x plus 3i. So when we get to binomials, we'll use the sum and product of the roots formulas, but when they are just monomials like this, I think it's pretty easy to just change the signs and do like we do when we have any constant number given to us. But now we want the polynomial, so here comes the long and tedious part of just foiling everything out. So I'm going to FOIL these two together, and I'm going to FOIL these two together, and then I'll FOIL the two of those together. So first we're just going to do x times x is x squared plus 1x plus 1x plus 1. And over here, you're going to FOIL these, so we get x squared plus 3xi minus 3xi minus -3 times +3, -9i squared. And let's simplify. And as you continue doing these, you might be able to skip a couple steps and do them in your head. So combine your like terms here. Our middle terms cancel out again. Remember, when they're conjugates, the middle terms will always cancel out. I squared is our -1 So now we have x squared plus 2x plus 1 times x squared plus 9. So again, as you're doing these, think about, oh, that number 1 we did when we had x squared plus 4, we factored x plus 2i, x minus 2i. Now I have x squared plus 9. That came from x minus 3i, x plus 3i. All right, and now we're going to distribute between these two sets of parentheses. So x squared times x squared is x to the 4th plus 9x to the 2nd. And a good idea, if you can, pause and try to do this on your own without using the video. Plus 2x to the 3rd plus 18x plus x squared plus 9. And then lastly, you're going to combine your like terms. So I have x squareds here, and I have then x to the 4th plus 2x to the 3rd plus 10x squared plus 18x plus 9. And no other like terms we can combine, so that would be our polynomial. Prime factors. So a quadratic factor with no real zeros from the real numbers, so no real zeros, is said to be prime or irreducible. So you can't reduce it anymore. Or irreducible over the real number system, or over the reals. So if it can't be broken down any further, we say it's prime or irreducible over the real numbers. So I'm going to do 2 of these, 3 and 4. I want you to do 3 things for each. So for numbers 3 and 4, here's what I want you to do. I want you to write the factors as a product of factors irreducible over the rational numbers. So they have to be all rational, no irrational. Then you're going to do it as a product of linear factors that's irreducible over the reals. And then lastly, I want it in completely factored form. So all as your linear factors. A product of linear factors is what I'm looking for. All right, so let's do number 3 together, and then I'll have you do number 4 on your own. So 3 is f of x equals x to the 4th minus x squared minus 20. So part A. First, we're going to do it so that it's just over the rational numbers. So this one has a 1 in the front, so I'm going to go straight to guess and check. I'm going to use x squared and x squared. I need 2 numbers that multiply to negative 20 that add to negative 1, which would be negative 5, positive 4. So far, we have all rational numbers. Can I break any of these up to make them and keep them rational? So do I have a difference of 2 perfect squares? No, because I have a sum of 2 squares here, and then I have a difference. Okay, so next we're going to move on to irreducible over the real. So now I just want real numbers, but I don't care if they're rational or irrational. So x squared minus 5. Think of it again as a difference of 2 perfect squares. We'll take the square root of x squared as x, and then we take the square root of 5. Well, it's not a perfect square, so we're just left with the square root of 5. Positive square root of 5, negative square root of 5. Then x squared plus 4. Again, think about it as x squared minus negative 4. So the same thing we just did. So x and x in the first two sets. The square root of -4, 1 plus, 1 minus, square root of -4 is 2i. So plus 2i minus 2. Oh, sorry, I went too far. Getting a little carried away. Too excited. Since we do that, we're going to do that in just a second. But those give us imaginary numbers, right? And I asked you to just do it over the real. So we're going to keep x squared plus 4. So anytime it's a sum, you're thinking it's going to be imaginary numbers. If it's a difference, you'll always have either irrational or rational numbers. So again, here, you're going to think x squared minus -4 for part C, because now we're just doing completely factors. So we're going to bring down x plus the square root of 5, x minus the square root of 5, and here's where we're going to break it down into our x plus 2i times x minus 2i. I'm so sorry about that. Just got in the math zone. All right, so that is completely factored form, linear factors, x to the first power in each of those factors. Okay, for number 4, you have f of x equals x to the 4th plus 2x squared minus 63. So I want you to take a moment here, and I want you to first factor this over the rational numbers, then factor it over the, make it so it's irreducible over the real numbers, and then see completely factored form. So pause the video, go ahead and do that, and I will tell you the answers after that. All right, so part A, you would have x squared plus 9 times x squared minus 7. Then for part B, any sums are going to give me imaginary numbers. So I'm going to keep that as x squared plus 9, but then I can factor x squared minus 7 as x plus the square root of 7 times x minus the square root of 7. Difference of two squares. I'm just taking the square root of 7 in the second two spots, square root of x in the first two. And then here, again, think of this as x squared minus -9. So you're taking the square root of x squared. Square root of -9 is 3i, positive, negative. And then just bring down your x plus rad 7, x minus rad 7. And then we have our complete factorization right there for number 4. Number 5. Find all zeros of f of x. X to the 4th minus 3x to the 3rd plus 6x squared plus 2x minus 60, given that 1 plus 3i is a 0 of f. So they're telling us that we know 1 plus 3i is a 0. If I know that so I want you to find all zeros and also write this out as a product of linear factors. Okay, so like I was saying here, if we know 1 plus 3i is a 0, therefore 3 dots in the shape of a triangle, we know 1 minus 3i is a 0. Because they always occur in their conjugate pairs. First step we're going to do is I want you to find a quadratic from the roots 1 plus 3i and 1 minus 3i. Okay? Because we want to find all the zeros from this original f of x right here. And in order to do that, we need to break it down a little bit. In order to break it down, if we know that we already have a 0 as 1 plus 3i and 1 minus 3i, I can find a polynomial or a quadratic that has those two roots, and then I can use long division to divide it to break that down a little bit further. So first I'm going to find the sum. Remember, your sum is just adding these two together, and the formula is negative b over a. So if I add 1 plus 3i plus 1 minus 3i, combine my like terms, they cancel, and I get 2. So I'm going to set that equal to 2 over 1. Then I want to find the product. So producta, the other one was, I'm sorry, I forgot to tell you, is samba. And then producta is C over A. So I'm going to take the product of my two roots. Now, one thing that students start to get confused on here is they start to add in x's sometimes, and then they forget the x's on the other questions. So I'm not asking you to find the factors. So I'm not saying write these as factors yet. I'm just saying find the product of these two roots. If they were the roots were 2 and 3, you would just multiply 2 times 3 together. So here you can FOIL this out. The middle terms will cancel. You can check it in your calculator, of course. I squared is negative 1, so we get 10. So I'm going to set this equal to 10 over 1. Now, we check our a's, and a is the same for both of them. A is 1 in both parts here. So I know a is 1. That means negative b is equal to 2, so b is equal to negative 2, and c equals 10. So as a quadratic, we'd have 1x squared minus 2x plus 10. Next step, I want to take this and I want to divide using long division. And this right here will become your divisor. So let's write this out. So we're going to take our original, which is x to the 4th, minus 3x to the 3rd, plus 6x squared, plus 2x minus 60. And I'm dividing that by my new polynomial up here, x squared minus 2x plus 10. All right, so some more review of long division. If you think you've got it, pause it and then just go to the answer. If you're really unsure what to do, I'm going to go through it right now. So x squared times what gives me x to the 4th? Well, x squared, so I'm going to line it up with the term that has an x squared in it. And then I'm going to distribute. Remember, you're only looking at this first term when you say what it goes into. X squared times x squared, x to the 4th, minus 2x to the 3rd, plus 10x squared. Also notice I did check for placeholders, but I didn't mention that. So 4, 3, 2, 1, 0, we don't need any. Now when I subtract, I'm subtracting everything. So I need to change the signs of all three things. 6 minus 10 is going to give me negative 4x squared. Negative 3 plus 2, x to the 3rd will give me negative x to the 3rd. This will cancel, bring down my next term of positive 2x. Now I check over here again, x squared times what gives me negative x to the 3rd? Well, that's negative x. And then I distribute. So I get negative x to the 3rd plus 2x squared minus 10x. And then what do I need to do? That's right, we're going to change our signs. So we get 12x. We get negative 6x squared. These cancel out. And we bring down our last term of 60, negative 60. Now I say x squared times what gives me negative 6x squared? And that would be negative 6. And then I multiply it over here. So negative 6x squared plus 12x minus 60. Nice, looking good. Change our signs. And everything cancels out. Good news. We have 0 as our remainder. That's great because we used what the problem told us was one of our roots, and we found the conjugate. And this polynomial, this quadratic right here, was from those two roots. So next up, I want to break this down even further, and I'm going to factor my quotient of x squared minus x minus 6. So you want to make sure it is factorable. If it's not factorable, you just use quadratic formula or completing the square. This one is factorable. So we'd factor that as x minus 3 and x plus 2. Now we have everything we need. So what we can do now is write our complete factorization. or as a product of linear factors. Same thing. So I've got x minus 3, I've got x plus 2. Now, the hard part here, off to the side, I'm going to show you how I'm going to do this. I have 1 plus 3i, and I have 1 minus 3i. So those are your zeros. I want to write them as factors. So once I write them as factors, here's when I write the x now. And just like if I had x equals x minus 3, positive 3 is the 0, I need to change the signs. So I'm going to take this and I'm going to negate each one. So this 1 will become negative, and this positive 3i becomes negative. Same thing here. I'm going to take x, negate the 1 becomes minus 1, negate the negative 3i to become positive 3i. So both signs change. This positive becomes negative, this negative becomes positive. So those will be my other linear factors. So a little bit tricky there, but make sure you change the signs of both. Make sure there's an x in each of these. Don't just write 1 minus 3i, 1 plus 3i, because those are your zeros. And now let's list out all our zeros. So x equals 1 plus or minus 3i. So that's the 0. There's no x in there. And then 3, and then also negative 2. So if I just set each of these equal to 0, I would get all of my zeros. Okay, let's do one more. I know these are tough. So I think we're on number 6 now. So that 5 was from the steps, how to do it. Okay, so number 6, find all the zeros. Of f of x equals 5x to the third minus 9x squared plus 28x plus 6, given that negative 1/5 is a 0. Also write it out as a product of linear factors. Okay, so for this one, since I'm given negative 1/5 is my root or my 0, I can actually just start with synthetic division because I have just a constant there that is my 0. So technically my factor is x plus 1/5. And we can write that a little bit nicer too. We can write it as 5x plus 1. So if you write it as x plus 1/5, you can use synthetic division. If you wrote it as 5x plus 1, then you can't use synthetic division. Because remember, it has to be x plus or minus a number. So we've got 3, 2, 1, 0. I don't need any placeholders. So 5, negative 9, 28, and 6. Negative 1/5 on the outside. Start by bringing down my 5. I always multiply by out here. If you can do this on your own, would be best. Pause it and then check back. Actually, I'm just going to give you the answer. All right, so you should have your negative 10 and 30, got 0 here. And go back to your notes with synthetic division if you need more help on that. And then we'd have 5x squared minus 10x plus 30 equals 0. So here we want to find the rest of our zeros. So we want to try to factor it. So maybe I factor out my GCF first and I get x squared minus 2x plus 6. So then I try to think what numbers multiply to 6 and add to negative 2, and I can't think of any because there aren't any, which means it is not factorable. Oh no. If it's not factorable, what do I need to do? Oh, that's right. I have the handy dandy quadratic formula, or completing the square works as well here, whatever you're more comfortable with. So I'll go through quadratic formula since that tends to be the one you guys like the best. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm just going to substitute in my values, which I think you guys can do on your own. So we'd get negative. So, and it actually doesn't matter. You can do either this one or you can do the original. I'm going to do this new one, x squared minus 2x plus 6. Since I just factored out that 5, you have nice small numbers. So 2 plus or minus negative 2 quantity squared minus 4 times 1 times 6 all over 2 times 1, which is 2. Type in the whole thing underneath my radical into the calculator, do that in my head to get negative 20. Before I can simplify, I must put it into simplest radical form first. That is so important. Before you reduce, then reduce. So simplest radical form, I'll pull out an I, and I can take out a rad 4 times a rad 5. So that would give me 2i rad 5 over 2. Now I can reduce either by looking at my 3 non-radical numbers that are all divisible by 2, or I can separate them into 2 over 2 plus or minus 2i rad 5 over 2, and then reduce. So we get x equals 1 plus or minus I rad 5. So our zeros would be negative 1/5, which they gave us, 1 plus I rad 5, and 1 minus I rad 5. 1 plus or minus I rad 5. Then I also asked you to write the complete factorization or as a product of linear factors. And for that, we're going to take each of our 3 zeros and rewrite it as a factor. So in parentheses with an x. So I'd have x plus 1/5. Then I'd have here x negate each one. So the 1's positive, so that becomes negative 1. The I rad 5 is positive, so that's minus I rad 5. Then we'll do the next one. X. Always start with an x if you're in a factor. Minus 1, since it's positive here, this is negative I rad 5, so it becomes positive I rad 5. And then even nicer if you rewrite this one as 5x plus 1. Again, if you solve that, you set 5x plus 1 equal to 0, you subtract your 1 over and divide by 5. So your root would still be negative 1/5. That looks a little messy. So 5x plus 1, and then you would keep the same, nothing else we can do to these linear factors, minus I rad 5, and x minus 1 plus I rad 5. Either one, as I'm okay with. All right, and that's it for us for today. Hope you had fun doing some math. Love polynomials. And if you have any questions at all, please make sure you let me know. Pie out.